Hello and welcome back. So we are in a creative mode world and we are attempting to build a 10k megabase. And we're currently doing production science. So this is our production science potion maker. The eagle-eyed among you will have noticed this is quite small. This is actually a 1/3 scale build. So this is producing 3,333 potions, slightly more. This is an engine build. You can see the electric engine machines here. We're faking in the lube for now, but that will change later. This produces the 1.2k of engines, electric engines needed to drive this. What we are missing is the other build, the other component, which is electric furnaces. So let's put down this machine and bring up electric furnaces. Okay, so this takes 5 seconds to craft. It takes 10 steel, 5 reds, and 10 bricks. Bricks, no problem. We just smelt a bunch of stone into brick. The advanced circuits, the red circuits, they may be a problem, right? We have to make quite a lot of them. The steel, now that's going to be unpleasant. Because steel in vanilla takes 5 iron plates to craft and takes 5 times as long to craft. So before you know it, your steel builds have got ridiculously big. Okay, so I have mathed this out. For the full build, if we were running this for a 10k build, we would need 648 smelters just making steel. Yeah. So we're not going to be doing a full build on one site for this. If we were to do a 1/3 build, that drops down to 216. If we did a 1/6 build, that is 108. And if we did a 1/12 build, that's 54. Okay, so 54 steel smelters with the 45 odd iron smelters to support them, that's a build with around about 100 assemblers. That is something you can build around a couple of drone ports. So we're looking at 1/12 size steel builds. Now, if we look at what's left, we need to make loads of red circuits. So we would need 160 red circuit machines in total. If we did a 1/3 size build, that would be 53, 54 red circuit machines. Okay, now that would be quite big if we didn't have to make the green circuits and the iron and copper plates on site. So we could do that if we didn't have to make the support items on site. But the whole point of this style of build is to take advantage of compression. So you bring in your ore and you don't let it out of your site until you have compressed it down into a very small number of items, so that when you're actually shipping stuff, you're shipping the minimum number of things you need to ship. So I do not want to end up, if I can avoid it, with a red circuit build where I have to ship green circuits in. So if we did a 1/6 scale red circuit build, that would be 27 red circuit machines. That would need 4 green circuit machines, 7 coils, 23 copper smelters, 12 iron smelters, and is it 3 or 4? I can't remember. 3 or 4 plastic machines, probably 3.5, so 4. That's a manageable size build. Now, add on to that, at 1/6 scale, 22 furnaces for producing stone brick. That's enough to supply 6 machines making furnaces. So what we're coming around to is having a self-contained site which has 6 furnace machines in it, fed by 4 steel builds. Okay, so we need to find some way of doing the geometry for this. So we would have a site which produces these furnaces, and it would have 3 furnace machines. Okay, we can't prod mod those. Sorry, 6 of these. And there's an open question about whether we want this site to be symmetrical or not. It might make sense to have a central... Right. We're going to have a central line. The question is whether we... do this, or whether all 6 of these go one side. But let's suggest it's like this for now. Okay, so then we would need 27 red circuit machines. Here we are. 27 of these. We need whoop, 12 of these. Where's the stone? I think that was my last supply of iron ore. Oh well. Right, so we need... oh, it's okay, we've got some more. So we need 27 iron ore, 22 stone brick, 23 copper. And again, we'd spread those around both sides. We need 7 coil machines. Four green circuit machines. And these numbers may shift around depending on if we do direct insert or not for the green circuits. It may or may not be worth it, I don't know, depending on the way the build pans out. I think we actually have one... Yeah, I don't know if we can get away with using an 11 beacon green circuit build, so we may be stuck with the 12. Right, so that's what we've got to build. And then we have to find a way to get steel into this. Okay, so looking at it, the builds which take in lots of material, let's have a look at these. So 10, 5, 10 over 5 seconds. Okay. Whereas this is 1 every 0.5. So we might actually be fairly even on what is expensive. I think we need to start building these and putting beacons around things. Okay. We also need to find a source of stone. Maybe logistics, I can just request some stone. Okay, let's get rid of auto trashing. Okay, so at the moment stone is set to 0. Let's change that to 50. There we are. Great. This is the easiest way I have found to get hold of ore in this game. You just stick it in as a logistics request in the cheat menu. If you've got all the cheats turned on, anything you request in logistics instantly appears in here. Okay, so I also don't particularly want these next to each other. I would like them spread out, which means probably interspersing them among stone furnaces. We need 22 stone furnaces in total. So that would be 11 on each side. So that would be a 14 long build for the first row. We may top that up with an iron smelter or something somewhere. So if you have 11 and 3, how do we intersperse these so that they are reasonably even? Okay, so let's start with that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 1, 2, 3. Now let's start arranging these. So if we did 1, 2, 3, dup, 1, 2, 3, dup, 1, 2, 3, dup, 1, 2. That's not ideal. If we did 1, 2, 3, dup, then 1, 2, 3, that. Then we have 1, 2, 3, 4, 5 in here. So we can't actually do this totally even. Okay. Okay, let's see if we've counted this correctly. So this should be 11 smelters and 3 assemblers. 11 and 3, yeah, we've done that right. Okay, so that's how we could do a front row, and then we would pick that up and we would flip it over and under to make the other half. Okay. We have 27 red circuit machines. Let's up that to 28 and divide by 2. Is that 14? Yeah, 14. So that's 7. Right. So that would be one side. We'd need the same the other side. Red circuit machines need plastic, then they need green circuits and coils. Okay, so we would then need, sorry, let's mark these with red circuit. So again, this is a half build. We'd take this thing and flip it over for the other side, potentially losing one red circuit machine. Right, so then okay, we need 4 green circuit machines. So that's 2 one side, 2 the other. Then we need 7 coil machines, but I'm going to call that 8. 1, 2. Right, so this is going to be coils. So that's what we need on the back row. Then we need 7 iron smelters. Okay, so how many in things in total is that in that row? That is 7 plus 6 is 13. 7 plus 7 is 14. 11 plus 3 is 14. So this is one machine short, not the end of the world, except we need 23 copper smelters. And 23 copper smelters is 24 if we round it up, divided by 2 is 12. So these are our copper smelters. We need of them. And that's not 3 rows anymore. Now, we have 3 rows, so we could do 4 machines spread across the 3 rows. We really want the copper to be co-located around this area, because we need the copper for these coils. Basically, we need the copper smelting by the coils. Okay, and I'm quiet because I'm thinking. I'm wondering if we could intersperse some of these 6 machines into this row. Right, so this is our half build. That's 30 plus 23, which is 53. And we have it across 4 rows. We need 53 across 3 rows. So 16, 32, 46. I need a calculator for this. Okay. Right, so the number of machines we have, which I've forgotten already, is it 53? Okay. To fit them across 3 rows would be 17 and so 17 on one row, 18 on 2 other rows. Just check this is 53. 30, 53. Yeah, there we are. Okay, so if this was 17 long, we're adding another 4 machines per build. The issue is this is now quite a long, this is quite a big build at that point, and it's starting to scream to me that we need to halve it. Except we can't halve it because we have an odd number of these furnace makers. Okay, let's try something. Because if we could halve this, that would actually solve some of the problems. We could shrink this down further, hopefully. Right, so if we had one of these and it was fully beaconed, okay, and let's get the handedness of the beacon overlap correct. It's shy to the left, hung to the right. There we are. Okay, so that's what we start off with. that's right. All right, can we put a power pole on this? Have I powered that up correctly? Yeah, I think so. That'll do. Okay, so we have 3 of these to start with. Let's get rid of that and that and that. Okay. Okay, we have 3 of those. I'm wondering if we can get it down to 2. Right, let's check the speed of this. So this is 315. Okay, what happens if we load these up with speed beacons? $270 is not enough. Okay, so no, we can't get away with adding extra prod mods, sorry, extra speed to this to ramp it up. So we are left with the build the size it is. Okay, so this is meant to be a furnace maker. Yeah. See, the copper smelters down here are only used for these coils. So I really want them to be close by. I kind of want them to be at the back. Not at the front. Let's delete them off here. Right, so to do that, I'm wondering if we moved... Yeah, this might work. If we moved 2 of the coil machines in amongst the reds, something like that. Okay, so then we can lose that and that. That's more than enough coils. We could then put that directly behind there and that there, so as to consolidate that part of the build. Then our 4 copper smelters go there. Okay. Then we have 3 copper smelters here. Okay. Then we have a green circuit and a copper. Okay, that's not entirely symmetrical. I kind of want to move some stuff around. This is going to be the green circuit. Okay, so then we would basically we'd have 12 of these. So 1, 2, 3, 4, 5 would go there. We then have 6 left to place somewhere. So 1, 2. So that leaves us 4 to place. And at that point we're looking at sticking them on the end of the build, really. That could work. Alright, let's start building this for real. And then once we've got one half of it done, we will just pick it up and flip it over. Okay, so let's get our book, put that down. Okay, this is not requesting iron ore, this is requesting stone. Great, then we can blueprint this. Give it the icon of stone. Or should we give it brick? Yeah, we should give it brick because that's the product. There we are. Then our book of things, this can go there. Great. So we have 3 of these. Yep. Then we have our electric furnace. Right, let's set this up with inputs and outputs. So out, in, provide, request. Okay, yeah, it's requesting a lot of stuff. I've got a feeling that's more than one stack inserter. Right, let's rate this. Yeah, it is. So I really need, well, I need a minimum of 2 inputs, but ideally 3. We're not going to get 3. So I need, let's get rid of that. Okay. This is far from being perfect, but we will do this. No, this isn't fully powered up, which is why those don't look right. There we are. That's powered up. Okay, so this is going to request steel, and instead of 262, it's going to request 131 reds. Right, then this is going to request bricks, no steel, and 131 reds. We will see if this works. It is possible that this won't work because the ARM will be trying to insert steel or bricks when this is run out of circuits, but we will see if this works. Okay, so that's our blueprint for a smelter. Don't want that on the blueprint. Okay, so we're going to change the icon here to furnace. And we're going to end the episode there because we're out of time. Next time we'll carry on building this thing. Okay. Thanks very much for watching. Like, subscribe, tell your friends, and I will see you again soon. Bye-bye.